Hey everyone, let's take a look at problems 20 and 24. The Bureau of Labor Statistics reported that about 5% of employed adults held multiple jobs. We take a 75-person sample. Okay, so for part A, they say, is it appropriate to use the normal approximation to find the probability of blah, blah, blah? The answer is no. Pause the video and think about why. The reason is, by the central limit theorem for proportions, we need both NP to be greater than 10 and N times 1 minus P to be greater than or equal to 10 to use an approximate normal distribution. But the problem is, right, if we have here that P equals 0.05 and N equals 75, well, then that goes ahead and gives NP equals 75 times 0.05, and you can just do it out. It's clearly less than 10. Okay? So we can't use the central limit theorem, so we can't use a normal approximation. The central limit theorem does not apply. It's possible that maybe it's normal, but we don't know that, so we're not going to do it. Right? We don't know the distribution of the unemployment rate, or of the multiple job employment rate. Okay. For part B, a new sample of 350 employed adults is chosen. That's looking a bit better. Okay. Find the probability that less than 6.5% hold multiple jobs, right? Okay. So we're finding the probability that P hat is less than 0.065. Okay? So first we just want to check. We want to check number 1. N times P equals 350 times 0.05. And I think we can tell that's greater than 10, right? Because if it were times 0.1, then that would be 35. So half of that is about 17.5. All right, so that's clearly greater than 10. And then it should be pretty clear that N times 1 minus P is 350 times 0.95. And that's very clearly greater than 10. Right? So we can use the central limit theorem. Okay? So we're using the central limit for proportions, to be clear, for proportions, okay? And we use the central limit theorem, well, I guess that means we're using Minitab, right? So if we go ahead and get out our Minitab, go over here. Might need to log in, yeah, we sure do. And we just open it right up, and we can go to graph, distribution plot, probability. Okay, and here our mean, right, is going to be, what is it actually? It is 0.05. And the standard deviation, that's going to take a little bit of calculation, right? If we go back here. Right, we know that the mean of P hat equals 0.05, and the standard deviation of P hat is going to equal, well, that's a little bit of work, right? It's going to be 0.05 times 0.95 all over 350. Okay, well, let's calculate that really quickly. Maybe also using Minitab. No, maybe just using Google. Right, that'd be a little easier. 0.05 times 0.05 times 0.95 divided by 350, and we would actually like to take the square root of that. So we can do that. Actually, no, we can just. Sorry, we'd take the square root of that. SQRT of that. 0.01. Yeah, 0.01, we'll just say. Actually, no, I think we should go out one more digit, so it's 0.012. Okay. All right, so we're going to put that into Minitab, right? 0.012. Okay, so we go to here, 0.012, options, and we're finding, was it less than 6%? Less than 6.5%, right? Okay. So less than 6.5%. Okay. And we're not going to auto-save this, right? Okay. Yeah, most of the time, right? Crop that super quickly. And we have our answer. All right, here. So the the probability that p hat is less than 0.065 is about 0.89, 89%. Right? So the probability that less than 6.5% of the individuals in the sample hold multiple jobs is pretty high. And that should make sense, right? Because we have a sample mean of 0.05 and a somewhat small sample standard deviation, right? 6.5 was over a standard deviation above the mean, the sample mean, right? Okay. Let's see if we can do parts C, D, and E, right? Probability that more than 6% of the individuals hold multiple jobs, well, same sort of thing, right? We just go back into Minitab, do our thing. Except we're doing right tail, and we're doing 0.06. And that's it. Okay. And that is our answer. All right, we're just going to crop this. So I'll just say here, similarly, probability that p hat is greater than 0.06 is approximately 20%. Okay? Right? We still have that the mean equals 0.05, standard deviation is about 0.012. Okay, so we still have that. All right, for part D, what does it say? Probability that the proportions in the sample who hold multiple jobs is between 0.05 and 0.1. Again, just another Minitab exercise, really. Here, here, here. We're going here. I think it was between 0.05 and 0.1. Okay. It's basically 50%, right? Is that really? 50? Yeah, okay. Just making sure. So that's a very strong, yeah. 0.1 is so many standard deviations above the mean. We could have even seen that coming. Right? So we get this. This. Okay. Here. Probability that P is, I should say, 0.05 is less than P hat, which is less than 0.1, is approximately 0.5. All right, and for part E, would it be unusual if less than 4% in the sample held multiple jobs? Somewhat unusual. Right, the probability that P hat is strictly less than 0.04, it's not quite a standard deviation below the mean, so not if unusual is 5%, then I think we're we're not unusual, right? Go here, 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 left tail, and we do 0.04. So not super unusual. I think we've seen that probability before. It's about 0.2, right? All right, so we just crop, done. Okay, so that's how you do problem number 20. Problem number 24, let's try to do this very quickly, right? Median weekly earnings is $837, okay? Let's see, what proportion of full-time employees had weekly earnings of more than this? Well, I think that's pretty straightforward if we know that the median was $837. It's just 0.5. And more than 837, right? No tricks there, right? Now, okay, now we take a sample of 150. What's the probability that more than 55% of them had earned more than that? Okay? So all of a sudden, we're saying, oh, okay, now we're interested in more than 5% over the mean. We have to take the, we're letting P equal, I should say, let P equals 0.5 because that's the proportion of people earning at least 837. Okay? Right? So the mu of P hat equals 0.5, and the standard deviation of P hat equals, it's going to be 0.5 times 0.5, right? 1 minus 0.5, divided by 150. Right, and actually, before we even do that, we should check that 0.5 times 150 is greater than or equal to 10. And actually, the same thing is true. Right, for 1 minus p. Okay. So anyway, what's this approximately equal to? Well, let's take a look. All right, so we have square root of 0.5 times 0.5 times 150, divided by 150, 0.041. Okay. I'll say 0.04, okay? So the probability that more than 55% of them, probability that P hat is greater than 0.55, well, again, just another Minitab exercise at this point. Now that we verify that we get to use the CLT. All right, so the mean here is 0.5. Standard deviation we said was 0.04. We're looking at the right tail, and it's 0.55. Yeah, not very high. 0.1056, right? .11. Okay. All right, part C. Probability that less than 60% earned more than 837. Well, again, you see this notation. You see how it's the same sort of thing every time. Well, I'm just writing this so that I know what to put into Minitab, right? All right, and we're just doing left tail, 0.6. Answer. Pretty likely, wouldn't you say? All right, and we crop this, and we crop this, and we get our answer. 0.9, 0.99. Extremely likely. Okay? Probability that we're between 45 and 55%. Again, we're just sort of here. Graph here, here, here. We're there. 45 and 55. Pretty likely. So again, we're here, here, and we crop this, and this, and we get that. Okay. And to be clear, right, I'm always using these probabilities, right? Okay. All right. Now, I'll let you think about part E, but given what we have here, that 50%, right, without even doing calculations, 50% of the population should earn more than 837, right? That should be even tighter, right? Right, that should be a bit tighter when we take a sample of 150. If, no matter what, right, I don't even think how we can do calculations too much. We have a sampling distribution right here. We have 837. No matter what the variance or standard deviation is, this is still 50%, this is still 50%. So if they're saying that if less than 45% of a sample earned more than $7,155 per week, yes, that would be very, very unusual, right? Right, again, $755 a week. That's just yes. Right, and I'll let you figure out exactly why. Okay, that's what we've got for today.